Hi everyone, welcome to the Dynamic Maths channel. Today we will be talking about logarithms. Logarithms are the opposite of indices. They are like day and night, black and white, addition and subtraction, and multiplication and division. To understand what indices are, I suggest to watch my previous video about indices, as you can see the relationship between indices and logarithms. If you're familiar with them, let's start by learning logarithms. Let's see how we convert an index function into a log function. Here we have a to the power of x equals b. A being the base, x being the power, and b being the number that is solved after computing these two numbers. We can rewrite this equation into another form, which is log ab equals x. Definition for a, b, and x still remains the same. To learn how to convert this, I have some tips for you to follow. Say we have a to the power of x equals b. We flip the equation over each other. We get b equals a to the power of x. After that, by using some imagination, we slide x and a to downwards. So that means when we slide it downwards, we have b, a, and x. The only difference is we have a log, which gives us this form. If you want to obtain the index form from a log equation, we just have to shift a up and we shift x up to the power. We get b equals a to the power of x, which is equivalent to the index form. Here we have three simple examples to convert from indices to logarithmic forms and vice versa. Let's start with the first question. Here we have 2 to the power 4 equals 16. What we do first is to flip the equation over each other, which is 16 equals 2 to the power 4. Then you slide 2 down to the other side of the equation, and you slide 4 in the right hand side of the equation. You get and you include log. This is the logarithmic form of the index form. Next, we do the same thing here. We flip the right hand side to the left hand side and vice versa. Use the same technique. Which gives us 0.04 equals minus 2. Now you include the log. And the third question, we have log 3, 9 equals 2. Here we want to convert it to the index form. To convert it to the index form, we shift 3 up and we shift 2 up. We get 9 equals 3 to the power of 2. This is the index form. By going through these three examples, you will learn the basics on how to convert an index form to a log form. There are two common log bases when solving logarithms. The first base is 10 and the second base is e. E is just a number which is approximately 2.718. The reason these are common log bases is because they do not come with the base notation, such as log x and ln x. Whenever you see a base missing in the logarithmic expression, you can safely assume that this means it's a log base of 10. If you see a ln, it means it is a log base of e. We will now move on to the first rule of the logarithms, which is the addition rule. Here we have two same bases with two different numbers. You can simplify it to become the log base of a, x times y. Let's look at a few examples. In the first example, we have log 3 plus log 4. As mentioned earlier, log with no base means log 10. Therefore, these two numbers have the same base and the addition rule is applied. Therefore, you will get log 3 times 4, which gives log 12. In the second example, there is an unknown and a number. You can use the same process again to solve, which is log x times 2, which gives log 2x. Remember, as long as the base is the same, you can always multiply the numbers. Here we have ln x squared plus ln a plus ln y. We have three terms. By using the addition rule, we can combine all these terms together. We will get ln x squared times a times y, which will give us ln ax squared times y. This is a simple demonstration on how to use the addition rule. Now we will be talking about the second rule, which is the subtraction rule. The subtraction rule is the opposite of the addition rule. Here we have x, a log base ax minus log ay equals to log ax divided by a. Let's look at the next three examples. They are the same examples except that I just switched from plus to minus. In the first example, we have log 3 minus log 4. We can use the subtraction rule to do the following. You'll get log 3 divided by 4, which is equivalent to log 3 over 4. In the second example, we have log x minus log 2. Using the same concept as in the first question, we can simplify as log x over 2. In the third example, we have ln x squared minus ln a minus ln y. Here, we can simplify ln a and ln y by factorizing minus. We can do the following. Ln x squared minus ln a plus ln y. You can combine these two terms by using the addition rule. You will get ln x squared minus ln ay. Then we use a subtraction rule to simplify our equation. The answer is ln x squared divided by ay. Here we have solved several questions using the subtraction rule. Just remember to focus on the order of the first term and the second term, as it will determine the numerator and the denominator. In our third rule, we have the power rule. The log power rule states that whenever the number x has a power of b, you can simplify this equation by shifting b to the back of the log. So you have to shift b to the back of the log, and you'll have b dot log a x, b times log ax. Let's look at a few examples. Here in the first example, we have log to the power log base 10 3 to the power of 4. We can simplify this by putting 4 to the back of the equation, and we will get 4 log 3. You can use a calculator to obtain the decimal values of log 3 times 4, but I will leave it as it is. In the next example, we have log x to the power of 3 over 4. You can use the same concept, and we will get 3 over 4 log x. In the third example, which is a bit different, but we can use the power rule to our advantage. We have log 1 over 2 to the power 3. If you still remember the index rule, we can flip 2 to the power 3 from the denominator to the numerator. We can do this by using the negative power rule, which is 2 to the power of negative 3. Now you can implement the power rule into this equation, which is negative 3 log 2. You have seen 3 different examples on how can we use the power rule to simplify our equation. The fourth rule is the change of base rule. We convert from base A to base C. The reason we do it is to convert it into a calculable value. Our calculators can only evaluate log base 10 or log base E. They cannot solve any other log bases. Let's look at the first example. Here we have log base 5. We need to convert to log base 10 or log base E. Let's start with 10. Here we will convert log base 5 to log base 10 using the change of base rule. Log base 10, and b here is 9, so 9 over log base 10, 5. We will then use our calculators to calculate the value of log 9 over log 5. The value will be 1.365. In the next example, we got log base 9 over log base 9 12. Let's do the same method as in the first example. Here we change the base of 10. We change to the base of 10. Log base 10 12 over log base 10 9. This will give us a value of 1.131. In the third example, we have log base 3 over 0.45. Log base 3 0.45. Use the same method to change the base to log base 10. We get log 10 0.45 divided by log 10 3. This will give us the value of negative 0.727. Because of the change of base rule, we can convert it into a value that we can calculate. We are shown in the examples below. Here are some extra tips for you to follow. In the first case, we have log a equals 1, which means that if you have a base number equals to the value on top here, it will always equals 1. Why? Because when we convert it into an index form, we see that if you still remember how to convert it to the index form, all we had to do is shift A to the right hand side and shift 1 up, which gives us A equals A to the power of 1, which is equivalent to each other. In the second example, we have log A1 equals 0. By using the same method as in case 1, we see that 1 equals A to the power 0, which is true because in index law, whenever you have a power 0, it equals to 1. Whenever you see 1 with any other base number or unknowns, you can equate it to 0. And the third case, whenever you have log A 0, it always gives an undefined value. When you put this value in your calculator, you'll find that you cannot calculate it. Let's summarize this session. We have learned about the index log conversion, the common log bases, and 4 log rules such as the addition rule, subtraction rule, power rule, and a change of base rule. Last but not least, we also learned extra tips on dealing with logarithms. If you have any doubts, please comment in the comment section below so that I can help clarify them. If you find this video helpful, like and subscribe to my channel for more videos. Don't forget to share this video with your friends. This is the Dynamic Maths channel signing off.